Right, here we go, we're ready to replace components. Shall we start again? Here we are, we're ready to replace components. There we go. Right, I've got some new capacitors here. There's one 2UF non-polarised electrolytic across the speaker terminals. I'm not going to replace that because I don't have any non-polarised. I could just reverse a couple and connect them, but I don't want to do that. Hopefully you can see what I'm doing. One problem is I've got to switch the board over. I've got the only 550 UF capacitor I had was this one, and I've got to try and replace it inside this one, which should be fun, but it should work. If not, I need to order some. This is actually at 50 volts instead of the stated 12 volts, which is probably why it looks to be a tight fit. So this one's coming out first. So what I'm going to do is, these were flow soldered by the look of it, which literally had a bath of liquid solder, and the PCBs would just run on down on like a conveyor belt system and go through this solder bath. It's quite an interesting process actually. So I'm going to add some fresh solder here to this well, 57-year-old board. I'll put something, this is the other side. Right, and then we'll start extracting. I don't have a vacuum solder pump. I can't see, for what I do, the value or the cost of one of those isn't worth it at all. So it would be quite handy, but it's not going to happen, so I'll spend what money I've got on other things. Right, so if I zoom you in, I've got to be careful how far I zoom in actually. So the joint I'm working on is this one here, and I should be able to just pull one end out now, which is good. I have, and the other end's here. And that pretty much flowed out straight away, and I'll just lift the end. So that's, I've actually got the camera filming upside down, if you like, so I flip it in a software like a video editor, so it's upside down, so everything I'm looking at on the screen is upside down at the moment, which is where it gets a little bit confusing. But you ask any person who films radios, radio repair on YouTube, and it's exactly the same. You're trying to get the best camera shots all the time, and sometimes it's very tricky to get one where people can see what you're doing, but you've still got everything in frame and like a wider view without having to switch back and forth. And sometimes it's easy just to hold the camera in your hand, and then people complain, oh, it's too wobbly. Well, whatever, it's just a bit of fun, isn't it? I don't think anyone's in it for making any money, not out of repairing radios on YouTube. But anyway, I guess if you are, there's some lessons coming. So what we're going to do is, this is undoubtedly completely knackered, but I'll put it on the component tester if I can find where I've put it, and we'll see what it comes out at. Right, I've found the component tester and connected it up, and as you can see, it's yeah, it thinks it's in circuit, So it's knackered, and my battery's knackered anyway. But yeah, you can see it. It thinks it's in circuit. So the trick to undoing these things, these red and black capacitors made by Plessy, is one, the label's going to come off. It's just like a printed label that's going to come off. So you know it's either off by now, or you're going to lose it anyway. So what I do is take a Stanley knife or some other sharp blade, and just on the edge of the label just roll round, making a cut. You don't have to go all the way through it, but at some point it'll start to cut through like that. And you've got upside down camera issues again this way. You've got two halves like this, and you can match them up when you've restuffed it, and just put a bit of sellotape around it to hold it all together, because it's only the shell for show really. So we'll dig the insides out. This one one's dry, so just got a pair of pliers, twist, and the whole lot will come out. It's still got some sort of moisture in it, but yeah, it's knackered. Now the big question is, will this fit inside? Oh yes, it sure does. Or sure doesn't. Oh no, where they've heat sealed it, heat sealed the two halves this way. It just needs cleaning up on the inside, and then this will slot in right alongside. So I'll wait for that to evaporate anyway, and then I'll go around with a scalpel and just clean up that little burr on the inside, and then we'll glue it back together and it can go back in. One thing I need to do, of course, is because this is a radial capacitor, I need to change it into an axial. Right, we've got the two halves. I've cleaned off the it's actually glued on the inside, and I can now drop the capacitor in there. No one will ever know. But what we need to do is we need to just get rid of the metal rivets at the end, and this is what I think the electrolyte leaks through. The little metal pop rivets, and there's one on either end. So just to show that this has been, I don't want the internal workings of the capacitor to affect this. So I'm going to remove the rivet thing here, and all I'm going to do is get a drill and a pin vise and just drill it out. Obviously you can use a power drill if you want. I find it much easier, especially when you're making videos, just to do it like this, and it'll come out at some point. I think I need to go all the way through. You could just punch it out, whatever's easiest, and just remember to remove that metal swarf off your mat when you've finished, because it is conductive, of course. No. This is the thing that takes the time. There we go. It's out now. all out. So my idea is, where's the other half gone? This bit goes in here, and then this bit will provide the feed through for the two radial leads. And what they did with these is, because the leads on these were pretty long originally, and sometimes you'll see them and they're standing upright on the PCB, and they just used to fold a lead down the side, which is, if you can see, it's slightly castellated. Hang on, when the camera focuses, it's slightly, you've got the three little slots, that's where they'd put the leads, so they bend them down these slots. So as you know, as regards using an axial capacitor, yes, that would be easier, but you know, I'll just fold one lead back underneath the capacitor and you'll just never see it. But that's the intention for that. So I'll get on with that and tape it up, and we'll see what it looks like in a minute. Right, here's the electrolytic all taped up. What I've done is covered the positive lead in a bit of shrink tubing, and the negative comes out the original hole, just so you can remember what's what or what, you know, if you were to do this. There we go. And annoyingly, the tape label stuck to the sellotape, so I couldn't unpeel it, so it's a little bit wrinkled on top here, but never mind. Right, what we can do is solder it back in, and see how that works. Right, that's one end. Pliers for the other end. See the hole, so right, one end, two ends, I'll just pull it through. That end and that end. Let's just see how it looks. Yep. Can't really tell anything else. Can't really tell that had been out now. Alright, let's just trim these extra bit of leads back, and we'll solder it back in. Get you a bit nearer in. Oops, that's the camera wobbling about again. Right. Right, there's the finished capacitor. Annoyingly, the yellow label stuck to the new bit of sellotape and I couldn't peel it off, but it's in there now. I've just got to solder it in, and that's what I'll be doing to the rest of them. Quite easy. Takes about 5-10 minutes to do on each one. Obviously it took me a best part of 45 minutes to film all this lot, so I'll get that soldered back in.